All right, so let's go ahead and get started. Now she's like, okay, okay. So you're thinking he needs help. Okay. We all do, so it's okay. All right, so last time we finished up and we were just beginning to talk about the entity relationship diagrams, right? So we talked about the fact that all of your database classes, right? Typically in school, we talk about one entity relationship diagram, but there are really two. And what are the two and why are there two? Oh, that sounds like such a great test question. If I was to just guess at a test question. Was that?
Complete and build.
Complete and build. Okay, so what's the difference between them? Because that hasn't gotten you full credit yet.
The complete will depict the entire scope of the landscape, whereas a build really indicates for a specific process.
Right, so complete should be done when? So you're correct in what you said, but when should a complete be done?
The beginning is
Already.
Already, right? Because it's not associated with a project, right? And how many times does a build have to, or a complete have to be created? Once, because once it is there, because as you put it, I think that's a great way to put it, right? It gives you the entire landscape. It gives you everything that is possible. You can look at it and see everything that is there, right? Okay. And what does the build represent? For a specific process, as you said, right? Okay. So what is the problem with our builds then? Our set of processes don't all come to one build. They have multiple builds that ultimately get created, and they can typically be overlapping. They don't have to be, but typically overlapping. And do they represent everything that's in the complete? They can, but they typically do not. So if, as a database designer, as a data administrator who's looking to say what databases need to be created, if all I have is this set of builds to look at, I have to tie them all together to understand exactly what has been built overall. And if I don't have a complete, I don't know exactly what is possible. And if I don't reference the other things that I've built, I may create a whole separate copy, right? That may not be an exact copy, but I'm going to have duplicated data or replicated data, and that's always bad. Why would replicated data always be bad?
More chance for error.
More chance for error, because if I have to update that data, I have to update it in multiple places. I have to know where they are. I have to make sure that if they are being updated, they are updated at the same time. Right? Because if they aren't updated at the same time, which one is the right one? And since multiple processes are updating different things at different points in time, you don't have one complete actionable view of the data, which is always going to be bad. Right? So a concept that you want to think of in terms of your databases is what we call SCA. So it's SCA, some single, complete, actionable view. Because that's what my data should represent. Because my data represents a state or a behavior. So at a point in time, this is the data that looks this particular way, and then as a company, we are reacting to that data in that way. And it may change it, but we only have one given state anything can be in at a given point in time. Yes,
Would you repeat that acronym, please?
SCA, S-C-A. Single, complete, actionable. And it's on a view, and the view is of your organization. Or you could have it that it's a part of your organization. So it could be a single, complete, actionable view of your inventory. It could be a single, complete, actionable view of your accounts. It could be a single, complete, actionable view of your customer. Right? I mean, it's the fact that I have all of this data, and all of the data related to whatever it is should be a single place or single instance. It should be complete, so all of the data should be in one place and accessible all at the same time. And it should be actionable, being I need to be able to action on the given state and either see what the current state is or be able to change the state to be something different because some action has ultimately taken place. So I got that, Cooper?
Yep,
More than you wanted?
that was perfect, thank you.
Oh, look at that. He thinks they're perfect. No, but other students think that way, so. All right, so what does the mini world represent on here? That's the organization that we are modeling, right? So what do we say is missing on here?
Complete ERD.
The complete ERD at the very beginning, right? So between the mini world and the requirements is going to be the complete ERD, and what else is missing there? The problem statement, right? Because I can't have a set of requirements to do something if I don't know what the correct problem is, and we said that that is the most important piece of your project, and you should be able to explain why. And so why is it the most important piece?
It defines what you're doing.
Yeah, it defines what we're doing. So if I don't have the right problem statement, all the rest of this can end up being wrong. Okay? So what does it mean to be partway down there? We have database management system independent and database management system specific. Why do we have the dashed line kind of in the middle there going into the logical design? Silence. Chirp, chirp, chirp. All right, Cooper.
Because the software that you choose to build and implement your database in will constrain the things that you can do on an application or an actual transaction level. But the function should be independent of the actual software that you have at your disposal.
Yeah, so you want to think about it. The top piece can be applied to any database management system. You are picking which database management system to use based on what you're defining up above, right? So I said there is a extremely large number of companies that have multiple database management systems. And why do they have more than one? Because each one has specific features that you want to exploit in developing the applications. So to decide which one is going to best fit, you have to do all the things at the top to then say there should be a step in there, and that logical design or my data model mapping is what database management system am I going to map this to that is going to give me the best result. Okay. And what is the other thing that was missing on here that, oh, I could put this picture on there and say just fill in the blanks. Oh, this would be great. Non-functional requirements, and what are those? Those are constraints, right? So it has nothing to do with the absolute functionality. It is about how is the system or the application that you're going to be developing constrained. So it could be based on availability. So it's available at certain points in time. It has to be based on, it could be based on performance. It has to perform at this particular speed, right? So we have lots of constraints that we have, right? I need to be able to take backups at these particular points in time, right? So all of that will play into this, so. Okay. All right, so we talked about the schema. So entities were what? Things, right? Just things we are interested in, and it can be logical or physical things, right? And entities are the things, and we have attributes, characteristics, right? There's lots of different names for that. Are the pieces of data that we have associated with those. And what is a domain? Right? It's given a entity and a set of attributes. What are all the possible instances that we have of that particular entity? So if I go in with a key, and what's a key mean? Well, it doesn't always have to be unique, right? So my keys are, I am going to query into the database using some values, right? So I may want to return not one, but all the things that fit to the key that I'm looking for, okay? So he mentioned a primary key, which makes it unique. Okay? But I could also have what we call secondary keys, and secondary keys do not have to be unique, but they are things that we are using as searchable fields. So for example, here at school, what could we do? We may want to find all these students that live in the city of Dearborn. So I would look in the address field for the city using a key, secondary key of Dearborn, to look at, in return, more than one person I would suspect, right? So I'm returning more because I'm not using the primary key. But if I'm looking for you, I should be able to look up with your student ID number, and that should uniquely identify you. Okay. Now, what if I went in by name? It could be that you are the only person with your name. I mean, how many people do we have of Cooper? Right? Probably you're the only one, I would think. If you run into anybody that's got your same name.
Not last name also.
That last name also, right? Okay, but, right, we have a lot of names that get repeated, right? And then you have to look using some other criteria to see which is the one that you wish to select to uniquely identify that person as the one that you want. Okay? So, point being is that we have primary keys. Primary keys are unique. Secondary keys, which are things that we use to look things up, which may or may not be unique. And we also have what are called composite keys. And what was a composite key? A key that is made up of multiple fields. Right? So, at the end of this semester, if I want to find out, or you want to find out, what is the grade that you got in this class, what do you need? You're going to need your student ID number in combination with this class, and what else? The semester, right? Because unlike you, my transcript is filled with W's. And when I had a W, that meant I had to take it again. So I had lots of W's followed by one that I finally got a grade in, right? So to uniquely identify a grade, I can't just go with my ID and my class. I have to know my ID, the class, and the semester. So in that case, I have a 3-part key, so it's a composite key to get me the unique value that is going to describe that. Everybody okay with that? That's okay. And what was a multi-valued? You have multi-values for the same exact attribute that I'm ultimately, when I define it out, not in the logical sense, but in the physical sense, I'm going to have to uniquely identify each of the individual pieces. But from a logical perspective, I just want to know that it's multi-valued. Okay, and so we have our example here of color for a car, previous degrees as a student, right? Could be schools that you've attended, right? All kinds of things associated with that. Okay. Right? So we saw that we could have hierarchies, and this is multiple levels of a hierarchy. So we have at the top level an address. Within the address, we have street address, and street address is broken down into its 3 components, right? So we can go, right? So in real life, right? Some of ours like this go to 15 or 16 levels deep, being composite. So right, it can be really complex because you end up wanting to potentially look at individual pieces or not. So as a database person, you have to say, what is the way I'm going to actually need to store this data? Because what can I do with this? I can store it at the address level, and within that I'm going to have the street address, the city, state, and zip code. But it's going to be harder if I want to look at any one of those individual pieces. I'm going to have to figure out a way to look for just what I want and be able to not encounter it in the wrong place, right? Especially we have lots of, for example, street addresses where the street name is a name of a city someplace. So I can't just look for certain words. I might have to know that they're separated by commas. Oh, well, what if they're not? What if somebody mistyped it? I mean, there's all kind of different ways that we can look at this, right? Or I could break it up into street address, city, state, and zip code. Or I could have the street address being the number, the street, the apartment number, followed by a city, followed by a state, followed by a zip code. I mean, there's all different combinations that we could have, right? So what is the importance of understanding that? You want to build your database how many times? Once, which means you have to understand what your data is, how it's going to be used, what changes are possibly going to be made associated with it. What is the way that are you going to have all of this data all of the time, some of the data part of the time, right? I mean, it could be all kind of different combinations. So this would be, here is the data that I have available, then you have to figure out all the rest of the pieces behind the scenes. Right. So our domain, as we said, is our list of all the possible values. So in our employee, right? If I go to look up an employee and I don't find them in the employee entity, they're not an employee. It's a true false scenario. If it's there, it exists. If it's not there, there's no other place to look. Right? That's our normal process. Yes, Cooper.
I'm sorry, this is an annoying question.
There is nothing you can do.
Is the domain a set of all possible values or all values that exist? Because those things are strikingly different to me.
Okay. So I'm using those in the same sense.
Okay.
Right? So, right? So for it to be a possible value, it has to exist, right? If it's a valid value, it has to exist in the entity itself.
Okay, but it's not all of the.
Right, so if I have a list of student, right? And I have a student number like you have, right? Only the assigned student numbers and the associated data records are going to appear in the entity itself. That's a list of all of the possible valid values I have at this point in time.
Okay, cool.
Right? So if it exists physically as data in the database, it exists. If it's not physically in the database as a record, even though there's possible data that would fill in those fields, but if it doesn't physically exist, it doesn't exist. Okay, so cleared up?
Perfectly clear.
And keep track of how many times he calls me perfect. It's two so far. All right. Okay, so what did we have here? We had the idea of, we had the vehicle identification number, or the VIN, and we had the license plate number. So we had the number and the state as the license plate number, and both of those should uniquely identify a vehicle. So what are these called?
Primary keys.
No.
Composite.
One is a composite key, the other one is not. It starts with a C though. Candidate keys, right? So these are candidate keys that can potentially, so either one of these can potentially uniquely identify an instance. Right? And once I uniquely identify the instance, then obviously it can be identified as a primary key. Okay. So, why is it referred to as a candidate key? Because it's a candidate. We haven't built our database yet, and how many primary keys are you allowed? One. So once I go through my list and create an entire list of what are all the possible candidate keys, the job of the database designer is to go through and pick which is going to be the one that you want to set up, and what kind of criteria would you use to select it. So let's think about it a little bit. So if you had a choice, would you pick something that is a single key or a composite key?
Single.
Right? Single is going to be easier to deal with than always having to ask for two pieces of data to then join together to get the unique result. Right? Okay. But that might be trumped by some other criteria. What other criteria might you make a decision on. In this one, for example. If people are looking up this car, what is the likelihood they're going to remember their VIN number versus their license plate? So if I have a use where someone is going to walk up and say, I want to know about this particular vehicle, and the only question that you can give them is, give me your VIN number or give me your license plate number, and they can't look anything up, the likelihood that you can give me your VIN number of your vehicle that you drove here to school in today is probably 0. Now, the likelihood you're giving me your license number is pretty small as well. I mean, I don't know mine, but I do know people that know theirs. So, but the point is that we need to understand not only from a technical standpoint, yes, a single one is always better than a composite. But if the usage of it is more defined to use a composite, you want to make it a composite, right? Because you want to make the application as simple and as easy to use as possible. Right? So what data do you have and how is it ultimately going to be used? All right. Okay. All right, we talked about the domains and all that kind of stuff. All right, so the ER diagram. So ER diagrams are extremely important because we have how many again? 2 types, but we typically don't just have 2 of them. We have lots of them, right? So in my world, I have how many completes? 1. But every major project that I have has its own build. So if I go back historically, I probably have 20 or 25 different build ERDs that all overlap each other, right? Because we created those uniquely for each project. But I need to tie those together over the top of the complete because it doesn't represent the entire complete. Okay? So it's kind of a one-to-many scenario that we are dealing with. Yeah. Okay? So we represent attributes in ovals. So entities or the things are in rectangles. Attributes are in ovals. Each attribute is connected to its entity type, okay? And if we have a composite, they're represented connecting to that particular oval. And if it's a key value, it's underlined, okay? Now, as we said, what's the 2 favorite words in IT? It depends, okay? So, right, in here they talk about that each key attribute is underlined, and in most places, you have a solid underline only under the primary key. We do underline the secondary keys, and we will be talking about something else called foreign keys later, so different types of keys. We have different ways of underlining, so if you look at it, you know whether it's a primary key, secondary key, or a foreign key in the process. So they talk about it being underlined, but I want you to understand that there are multiple ways to look at the way that we're actually going to do this. And multi-valued attributes are displayed in double ovals. All right, so the notation that we have for ER diagrams, right? So if we look at this, okay, the really good news is that it's pretty common. The bad news is there is no direct standard associated with the way that we draw these. So depending on what tool you use, the way that your company has it, you'll see some different forms of it, and this has way more stuff than you will probably ever see on one. Right? Right. So we'll go through some of this, and some of this is in the examples as well, but again, right, we tend to describe this in way more detail in the theoretical or the classes like this than we actually really apply in real life. Okay. So if we start at the very top, we have an entity. So an entity, as we said, is just in a straight rectangle. Right? So just put the name of the entity in there, and that represents this. Okay? We have the idea of a weak entity. Now, what a weak entity is versus a regular entity is if I have a composite key and I have a relationship to another entity and it's only based off of a piece of that, then it's called a weak entity because it's not based off of the whole thing. Right? So, just as it's not one that you would see, but it gives you the idea. We talked a little bit earlier about what did we have that uniquely identified your grade. We had student and a course, right? So, and the semester. So, right, if that was our key of something that we were creating about the list of all the grades that you have, and the only association that we had off of that entity of the grades that you've received is to student. And what's student based off of the primary key? Your ID. That's a weak entity because it's not based on the entire key value. Right? Similarly, if the only thing you are associating that with was course. Right? So the idea is that I have one entity that I've created with a key, and another entity is associated with it that's only associated with it as part of it. So we'll see some examples of that later. Typically, if we have these, we're not going to create them that way. Right? We break them up. So again, we talk about these, but typically by the time that you go through the process, you eliminate all of those, so we don't really see them on that ending diagrams. Okay. All right. We have relationships. So relationships are between the entities. You have some relationship. As a student, you are taking a course. Departments offer a course. Students enroll in a course, right? You have some relationship that you have, right? So they have another thing right under that. That's the double aligned one, which is an identifying relationship, right? So again, I don't have any identifying relationships on my diagrams. I just want to know there's a relationship, right? It's just too much info and trying to keep it all, these different diagrams, too much work, right? But identifying is, this is something that is uniquely identifying something. Okay? So attribute is a single oval, a key attribute has some sort of underline associated with it, the multi-valued has a double oval, the composite attribute has a set of attributes coming off of the main attribute. Derived attribute. So this is a dashed oval. So what would a derived attribute mean? It's what? Nope. So it's not inherited.
So age is derived from the date of birth.
It's derived from the date, but what's that mean?
You don't store data for the age. You store how to get the age from some other column that we do store or attribute.
Yeah, so if I wanted to know the age, it can be derived if I have somebody's birthday. If I have your grade I can go through all of your grades and calculate your GPA. Right? So it's something that we can derive from data. So why would we put something that we can derive on our ERD?
It's frequently accessed.
Yeah, it could be frequently accessed. It's something that we want to know about, and it is something that we have to determine whether we're actually going to store the derived value on the database or not. But what if it's on the complete? That's just saying that it's possible to get this and it's something that we frequently use. Okay. So, the idea of derived is that somebody has talked about it, you want to be able to point out where this resides and what you would associate it with, possibly where it is derived from. Right? Okay. Right, so we have also the idea down at the bottom, we have the relationship that we have, so, right, we connect them with lines. So the total participation line, which is the next one, so they show 2 lines on one side and 1 on the other, means everything has to go into that relationship. Again, I have not seen that one on any ERD I have ever created. At any company I've ever been at and looked at an ERD, I've never seen that on any of those. So it's really nice that they have it. Yes, it would be great information, but never used it. Because I'm going to build a database the same way whether it's a total participation or not. Right, so it's, yeah, nice to know. Okay, the other one that we have down here that you will see a lot of and have to deal with is what we call the cardinality. So cardinality is our numeric relationship. So not just that the relationship exists, but is it a one-to-one relationship, a one-to-many relationship, a many-to-many relationship, right? So what is the relationship that we have, right? And what's an example of a one-to-one?
Student ID.
It's what?
Student and student ID.
No, so that is student ID as an attribute, right? And that's an attribute on the student, right? This is one-to-one between entities. So you as a student have an account, right? You don't have 8 accounts at the university, you have 1. And it's actually a mandatory one. You can't be a student without an account. An account can't exist without a student, right? So that's another way to look at the weak entity kind of thing, right? Is you can have a student, right, technically, right? But the account can't exist without the student. Right? So it can't exist kind of on its own. Right? So we have ways that so if the school set it up so any incoming students that applied get put on as a student into the student database, but unless only the students that are accepted have an account, then that would be an example of a weak entity because the account can't exist without a student, but a student can exist without an account. Okay, so one-to-one is there is only one way that they can, right? If I have 1, there's 1 over there, and right. Okay, so 1 to many, right? And then obviously many. So we have, many to many is really common. 1 to many is not, but they do exist, right? So we always go through and we identify cardinality because what's the importance about knowing the cardinality of all these things? That's going to help us define what the database structure is going to look like and how I can relate the data together. Right? So back to our example that we gave about students taking courses. You as a student take multiple courses, and each course has multiple students. So that's a many-to-many relationship. Okay. What about a course to textbooks? A single course is going to have potentially multiple textbooks associated with it. So one to many. Right? So we have things in the real world that we model on this, but when we create these things, I'm going to have a student database. I'm going to have a course database. I'm going to have a textbook database. I'm going to have a department database, right? They're all independent of each other, and I need to link them somehow. So in linking them, the way that I physically am going to link those together, seeing the relationship that we draw on here, the cardinality is going to tell me how to create it. So we'll see examples of how to do that. All right, so if we look at our example here, we have our car, right? The car has a registration and vehicle ID that we have, right? Okay, the registration is made up of the state and the number associated with that, so it's right? So what's ultimately our composite key associated with this? We have three pieces: the state, the number, and the vehicle ID are all three pieces that you need to know to get the unique vehicle. Okay. For the car itself, we have a model, we have the year associated with it, we have the make, and we can have multiple colors associated with that. Okay. So if you look at the top in A, we have the drawing, right? So this is the ERD diagram associated with this. And in B, we have the structure definition of the way it would look. So for car, we have a registration made up of the number and the state, the vehicle ID, and again, typically what they don't have on here, but you would really have in reality, is those would be underlined to indicate that those are the keys. So I don't like the fact that they didn't do that. But make, model, year, and in color, we have those in braces because that's indicating that it's a multi-valued attribute. Okay, so any questions on that? Okay, so we were talking about in the example that we had a conceptual design for the company database schema, right? So based on the requirements, we identify 4 entity types in the company that we are dealing with. So we have department, project, employee, and dependent. Okay, so this is, before we go on to the next page, I want to make sure that we talk about, because this is a common mistake that we have. So what are we modeling? We're modeling the company, right? And what's this class about? Databases, okay? So what we are seeing here with this slide and what you hear in this class and what you will hear outside of this class and you'll hear from other instructors and you hear at different companies and the way that they do things is database has tons and tons of meetings. Okay? So, what is the issue of what we just described in this slide right here versus what we have been talking about all the rest of today? Hint, we just talked about the word database, and where does the word database appear?
After the word company.
After the word company. Okay? So in this context, they're saying that the entity type in the company database. So this is, the company database is made up of all these other databases that are internal to it. Right? So where all of the context that we've had about databases so far have been department, project, employee, dependent are going to be their own individual databases. Right? So we have individual databases and we have large-scale databases that are composed of sets of smaller databases. And actually in some of the database management systems, based on the context, you have the word database and it can have multiple meanings. It's great. Right? That's why your database people get paid so much money because they have to figure out what all these strange meanings are. Okay? All right, so I just wanted to point that out because the slides make it sound so easy, but the words, and I want you to understand all the meaning behind the words. Okay? So, we are creating, in this case, 4 entities. They would translate into individual databases inside a database management system. The collection of all of those can be considered a database. Okay. So again, I just wanted to make sure that you're all okay, because that's going to be interchanged all the way through all the different slides. And if you pick up different textbooks, if you go look at some YouTube video, if you talk to a different instructor, if you talk to somebody at work, they all talk about it in slightly different terms. So based on the context, you have to figure out what exactly they're talking about. So Cooper, you had a quick,
Never, I redact my question.
you didn't even ask it.
Yeah, I know.
Did I answer it at least?
Yes.
You're not just saying that, are you?
I don't think it's a helpful question for me or anybody else. I'm gonna keep this one.
Sure, now I want to know what it is, but it's okay. All right. So if we look at this picture, right? So at the top we have department and we have the name of the department and the number associated with the department, and we have a manager, we have multiple locations, and we have a manager start date. Does that seem right? If you were to think about that, would you say that's right? Okay, so Cooper says no. Okay, so think about it before you answer. Are you going to agree with Cooper or not? So, what do you guys think? So, how many agree with Cooper that this doesn't look right?
There's nothing at stake.
Yeah. It's not like your A plus that you currently have is going to drop because you agree. Okay. So all of you think that this is okay? No, except for Cooper, right? And you, right? Yeah. Right. So why don't you think this is okay?
Because I feel that the manager start date, that belongs to the manager, so not with that information.
Well, you're trying to keep track of who the manager
But
is.
you can do it by the ID. That's a department, and then
Yeah. So in looking at this, right, what should be associated with the department? The data associated with a department, right? Now, you could make the argument that there's a manager of a department, I want to know who that is, but the scenario that you're looking at is, I have this other entity called employee that I'm also keeping track of, and I would think, if I'm just think about this a little bit, that a manager is probably an employee as well. Right? So, but the way you kind of want to think about this is actually okay from the standpoint of, this is kind of a first pass, right? So, we never, ever, except of course in classes like this, right, get it right the first time because it's so complex and you're trying to just get it and you go through and revise it and right, here's where things are going to go. So for a first pass, you're just kind of going, what are all the things about a department? I have a name of a department, I have a number for the department, and it's in multiple locations, and it's they're going to have a manager, right? And oh, my key is going to be name and number. Does that make sense to have name and number both as part of the key? Do I need both?
Maybe.
Maybe not, right? If I can have multiple numbers along with multiple names, I may need both. But if my numbers are unique, I probably don't need the name. And if the names are unique, I might not need the number. So maybe not. So this is kind of maybe your first pass at a candidate key selection. Okay, what about project? Location, name, number, and the controlling department. Okay. All right, so employee, oh man, look at the employee, right? Works on projects and hours, and got a supervisor, and
Shouldn't name be a double oval?
why would name be a double oval?
Isn't it a multi-valued attribute?
How many names do you have? Well, so what aliases do you go by, Cooper?
Well, I was gonna say 3, but I see that, okay, yeah. I got you.
Okay,
Yeah.
I'm gonna have to go look you up, Cooper, because you clearly,
People do change their names. I haven't done it.
but you only have a current name.
That's true.
You may have had past names. Coopster, right? Something really exciting. But if you did have multiple names or aliases, yes, you would have to do that. Okay. And dependent down there. Okay, so we have. Oh, look, the initial design is typically not complete. Well, of course not. Right. Some aspects in the requirements will be represented as relationships. So we have 3 things that we are really looking at, and it's entities. So they're types and their sets, which is kind of your domain. We have the attributes, so simple, composite, and multi-valued, and there are relationships, and their relationship types and relationship sets, right? So again, in reality, we're just looking for, does the relationship exist or not? Not necessarily all the detail behind it. Okay, so a relationship relates 2 or more distinct entities, so we actually have 3-way, 4-way, sometimes 5-way relationships to create things. They are typically pretty rare, but they do exist. So you need to know that they do exist. But in general, it's 2 with a specific meaning, right? So an employee works on a project, an employee manages the department, right? So we are trying to look at what are all the different relationships, and the point they're trying to make here is that we can have relationships that more than one type of relationship between the different entities. Okay, so in our case of this, we have the employee that is working on a project, but I could also have an employee that's managing a project. Right, so there's two different relationships between the same entities. Okay. Okay, so relationships of the same type are grouped or typed into a relationship type. So the works on relationship in which employees and projects participate, right? So we're looking to manage those. And the degree is the number of the ones. So it's typically a binary, meaning between those. But I have the next one that you typically find in number kind of order would be unary. So it's a relationship back to itself. So employees managing or supervising other employees, for example. Right? Goes back to itself. Okay, so that's a very common one, so we see that next. And then I said tertiary for 3 and so on that we have. Okay, so again, if we want to just see it in a picture format, right? So an employee, so the entity is on the left, the entity is on the right, and I have the works for relationship. So it's a relationship, and the fact they number those kind of in here, and I can say that in here, for example, that employee E1 works for using relationship 1 to department 1. But I also have employee 3 using relationship 3 hooking into department 1, right? So I can, we should be able to do this type of mapping. We don't do this, right? But we could, this is what the resulting database that's created is going to actually do. It's going to do this kind of mapping through a relationship from one entity to the other. Okay. Right. So again, this is another many one that we have. Right. So again, just the other one was department. The other one, so this is projects. Okay. So the relationship type that we're talking about is the schema depiction, description of the relationship. Right. So again, ultimately, where's our schemas go? The metadata, or the other word for metadata is the catalog, right? Okay, and the database management system is using that to determine how to access the data, what the data looks like, where it's at, all those kinds of things, right? Okay, so the schema is going to describe it, it's going to identify the relationship name and the participating entity types, and then we have constraints that we have on that. So an example of relationship constraints is we have the idea of what we call sparse relationships. Okay? And a sparse relationship is where there is not a complete relationship between all the entities in one set to the other set. Only a subset of those apply. Right? So, for example, right, here at school, what do we have? You have students that are active students. Right? And we have courses. Okay? And in a given semester, you have students that are taking courses, so that relationship is going to exist. Okay? But what do you also have? You have people, especially in the summer, that they're active students, but they're not taking any courses for that semester. So it's a sparse relationship because not every student is going to be taking a class in a given semester. A lot of them are, and I can have a relationship that does it, but it's not going to be to every single one of them. Right? So, things like that. Okay, and the relationship set is the current set of relationship instances represented in the database. So it's what is the current state. Right? And as we said, what does our data in the database represent? The current state that we are at. We can change the data, but that will change the state that we are currently in. Right? All right, so each instance in the set relates the individual participating entities, right? One from each type, unless it's a sparse one. In the ER diagrams, we represent relation types as follows. So our diamond box represents the relationship type, okay? And then we have the lines that connect them to say that we're there, okay? Okay, and we don't have arrows, right? So none of this, right? We cannot think of a entity relationship diagram as a flow. There is no flow. So there's no arrows. You don't go in any given direction. You should be able to read the diagram, and we put the wording in the diagram top down, left to right. But you could also flip the diagram around completely, move things around, reword things, and it would still represent the exact same thing. But we write it one way, but you can read it back the other way as well. All right. So one of the key things about creating the entity relationship diagrams is you actually performing the idea of going in both directions to make sure that that makes sense to set up those kinds of relationships. Okay. Okay. Okay, so in looking at the requirements, we had 6 relationship types identified, and all are binary, meaning they are 2, right? So we have employee works for a department, an employee manages a department, the department controls a project, the employee works on a project, right? There's supervision between employee as a subordinate, right? And so I would argue that this would not necessarily be a binary relationship because it's, the supervisor is, right, you see employee in both places, right? So, right, I would argue that they are wrong in that, but I'm not perfect either. Okay? The dependent is a dependent of an employee, right? So again, one of your key things to look for, if we look at these steps, is to do what? You have to identify all of the entities. That's what we did first. Then you look at the entities and you say, is there a relationship between the other ones? Based on what you know. Okay, so if we were to look at the diagram that they have associated with this, right? So if we look at it, we have all of the different scenarios here, right? Of employee, department, project, and dependent, right? We have the 6 different relationships that we've identified there. We have the attributes that we have associated with those, right? And the numbers and the letters on there, so the M and N and the ones are representing the cardinality. Right? So if you look at, right? Now see, this is where we can kind of get into trouble on some of this. So what about employee manages a department? What are we saying there?
That only one manages one department, and that only one
Yeah, but that's not really clear on this to me, right? So the way that I would want to see this is an employee manages 0 or 1 department. And if I go the other way, a department is managed by 1 and only 1 employee. That's the way that I would want to see this depicted. Okay? Okay, what about the employee works for a department? So the employee works for 1 department and a department has N employees working in that department. So again, we write it one way, but you can read them both ways. Okay. Okay, what about employee and supervision? An employee may supervise N employees, and an employee is managed by 1 and only 1. And again, I wouldn't call that a binary like they did. I would say that that's a unary relationship. Okay. Okay. Employee can have N dependents, and a dependent can only be associated with 1 employee, right? So you can read these. Right? So this is nice, but this doesn't really tell me the right story. Okay. Okay. So we can look at different ways that that's going to happen. Okay. So in the refined design, some attributes from initial entry are redefined into relationships, right? So the manager of a department, right, so it manages, right, works on, right, and departments there, so right, so again, the scenario is they start off with these wonderful entities, they look at attributes, they look at what keys might be there, they then added the relationships, they added the cardinality, they reduced some of the attributes into relationships, right? So there's a process to follow in doing that. So in general, more than 1 relationship type can exist between these same entities. So manage and works on are different relationships between the same 2 entities, for example, right? So between employee and department, right? So different meanings and different relationships ultimately exist. Right, so we talked about the constraints, right? So they talk about it in terms of ratio constraints. No, I've never heard it that way. We just talk about it in terms of the cardinality that you have, 1 to 1, 1 to many, and many to many. Okay. Okay, we have the existence dependency constraint, so it's minimum participation, right? So sometimes that's our, do I have to have 1, right? Can I have minimum of 2? Can I have minimum of 5? We can have different ranges that you want, right? Okay, so we have different types of participation that we can lay out. Right. Okay, so we have, again, you can flip these around, have a 1 to many, or I can set it around to a many to 1, right? So depending on the order that you put them in. But again, the idea is just to set up so we show the different relationships that we have in place. Right? And then the many to many scenario. Okay, so our recursive type, this is the unary, where we're talking about this relationship type between the same entity in a distinct rule. So it's a self-referencing, right? So in our case, this is the supervision one. So employee participates twice in 2 roles. One is the supervisor, and the one is the employee who is being supervised. And the relationship is 2 distinct employee entities, and so it's depicting one in each role, depending on which way that you are going through. So as we saw, both participants are the same entity, so it starts and ends with the same one, right? Okay, so, and we just label those to distinguish it. Okay, so again, you are, at least I have never had anybody draw this, but they're trying to depict the idea and see it in picture format. There's the different rules. Okay. So again, this is back to the example that we have, and where we are now, they've added, if you look in the employee supervision, they have labeled the sides associated with that, so you know which one is which. Because obviously coming from and going back to the same entity, so you want to know what the roles are. So that's the only difference between this. Okay. So as I said, our weak entity types, right, are an entity that does not have a key attribute that it is identification dependent on another entity type, right? So again, we have multiple definitions of what weak entity is, right? A weak entity must participate in the identifying relationship with an owner or an identifying type, right? And so again, it's the idea of that whole partial key kind of scenario that we kind of laid out. Right, figured entities we have are in the identifying relationship. So in our case, the dependent entity is identified by the dependent's first name and the specific employee. Right, the name of the dependent is a partial key. Dependent is a weak entity type. So again, right, it's a lot of words here, but the basic gist of it is you can't have a dependent if you don't have an employee. And you can have an employee that doesn't have any dependents, right? So a lot of words just to tell you that. Okay. But they have to make books big. So, yeah. Okay, so attributes of the relationship types. Relationship types can have attributes, for example, hours per week of works on. Right? So this is where it nicely fits into the, what's the two favorite words? It depends, right? So there are multiple companies I've been at, multiple other instructors I've dealt with, multiple textbooks I've dealt with that will say the attributes that you have, if they're going to be off of a relationship, can only occur on a many-to-many relationship. And the reason for that is typically when you have a many-to-many relationship, you are actually building a database that represents that relationship. So it's very easy to create a attribute because I already have a database that I'm building associated with that. Right? Other companies I've been at, other instructors I've dealt with, other textbooks, they all talk about the fact that, well, you can have it off of any relationship, but then you now have to figure out where it goes. So I'd rather have it, and I know where it's going to go, so put it with, but again, depending on where you're at, right? So either way is going to work. The key thing is it's depicted somewhere. There is no right and wrong way to do all of this, right? So all of you could be given the exact same scenario. You could all come up with an ERD associated with it. It could look exactly the same or completely different in terms of the way that it's arranged, the names that you use, but as long as all of this stuff is there, it's correct, right? So it's just like programming class. I hand out my programming assignment that they have due next week, and all the programs are going to be slightly different, but they can all work correctly. So there is not one exact way to do it, so just follow whatever company wants. Yes?
I'm wondering if we could take a 5-minute break.
or what the policy is that you have for taking breaks during this period of time. Is it, can we just get up and do it ourselves, or how would you like us to manage that?
Well, I think the best way would be to see what everyone would like to do.
Sweet, yeah,
Okay,
that's what I meant.
Okay. Okay, so the choices are, so here's why I typically do not give breaks, is because 5 minutes turns into 10 minutes and so on, right? So we never get back on time and get started. Because, you know, I don't want to start with a bunch of people gone. Right? That's not fair. But it's also not fair to me that everybody's gone longer than we think it should. Okay, so I typically, instead of giving a break in the middle, I just stop earlier because I should have given you some time in there to do that. So the opposite one is you have a set time. You have 5 minutes. You only get 5 minutes, and whether you're here or not, I just start talking and where we end up. So I'm okay either way. So why don't you, Cooper, being the person that suggested this,
Yeah.
why don't you take a vote, and I'll let you count.
Sure. Yeah.
Right, and then you give me the result of that, and then we will do what the class wants to do.
Alrighty, you guys ready? So, to remind everyone, the options are get out 10 minutes early. Can I add another option, or is that completely ridiculous?
Oh, I love negotiations, Cooper. This is really good. Right? I think the people around you should muzzle you, but that's okay.
Sure.
Right? Okay. No. What option would you like to propose? And then I will let you.
How about
know.
this? We'll vote on today. If you have strong feelings, please email me. I'll make sure that it's easy, and then we'll actually think of a way to do it, not on class time, so that way it doesn't respect our professor. But today, what do people think? 7-minute break or no 7-minute break? And I'm eating up part of that right now. So raise your hand if you want a 7-minute break. Great. You get to decide when it is, Professor.
Right now,
Great.
since you've already used 6 minutes of it.
Yes. 1 minute, everybody. Thank you.
Okay.
I'll post something on Canvas and we can all work it out then. Sorry, thank you.
I talk for the same amount of time no matter what, so it doesn't matter. All right, so we're going to start while Cooper's like typing away and not paying any attention to what we're going to talk about anyway, so it's okay. All right, so we were talking about the fact that we can have attributes off of relationships, and in general, they, as we said, they will tend to be off of many-to-many relationships. So the example that we gave earlier about the grade is actually another example of the exact thing we were talking about, right? It would be, what is the relationship? A student, being you, taking a course, and we said, as a student, you can take multiple courses, and a course is going to have multiple students, so it's a many-to-many relationship. The fact that you have taken a particular course would be an entry in that relationship, right? So if we were to draw it like they depicted it, right? You as a student on one side, the course that you're taking on the other side, and you have the relationship, okay? Now, what we know about the relationship is that grade that you get is only associated with the relationship. It's not you as a student. You have multiple grades, so it can't be, there's not just a single grade for you as a student. And it's not for the course. There's no grade for the course. It's a grade for a student. So to get to a grade, the only place to get a grade for a course for a student is that relationship. But as we said, in our example that I could have multiple grades off of that relationship because you could take the course multiple times. I need a third component being the semester. So in this case, I have two attributes off of the relationship. It's semester taken and the grade. And the semester taken is part of the composite key to make the grade unique. Okay. So an example that they are working on here is the works on, and they want the hours per week. So if we look at what they depict there, and we'll see if this makes sense. Okay. Okay. So we have employee works on a project, and we have hours. So do you think this satisfies the requirement? Okay, so off of works on, many-to-many relationship, we have hours. So does that depict or satisfy what we have been asked to do, which is, okay, we want hours per week. So how many of you think that this satisfies that requirement? Nobody. Okay, so clearly if you aren't raising your hand, you have some reason to think that it doesn't. So why doesn't this satisfy the requirement?
There needs to be some sort of date.
Yeah, right. That would depict what are the total number of hours that an employee has worked on the project, not in the hours per week. Okay. So again, the point we're trying to make out of this is they gave you a requirement. They've given you a picture. It doesn't depict what really satisfies the requirement. It has satisfied part of the requirement, but not all of it. So you have to, right, this is why database design and database management is really hard. You have to think about all the possibilities. What do you have to do? Because we want to build it once, not go back and change it. Okay. All right. So again, the notation for the constraints or the cardinality, right? So 1-to-1, 1-to-many, many-to-one, or many-to-many. Right? So we show it on the appropriate lines, right? And we have the participation constraint, right? So again, the total and partial dependency, so that's that single and double line that they talked about. And again, right, the textbook talks about it, but at all the companies that I have worked at, so all 5 of them, I've done ERDs at all of them. They've had ways that, or formats that we should follow, and none of them had this on there at all. So it exists, you need to know about it. We have other ways to depict it, but this is the way that the book talks about it, and it's in the example, so I want to make sure that we talk about it. Okay. So an alternative, we have min and max notation, right? So again, the scenario is instead of just having a value, I put indicators on for each one of these. So I have 2 numbers associated with each cardinality, a minimum and a maximum. So they give you some examples of that, right? So in our case, an employee, right, and a department, I have the min and the max associated with those, depending, right? So a department is going to be managed by, right, 1 employee, and the employee is going to be managing 0 or 1 departments. Okay, so the idea is that you're looking at it and looking away from the type that you have. So in switching it around, this is kind of the scenario that they have, looking at that in the other direction. Right? So, this is okay, right? So again, I've had a couple places that do it this way as well, but I'm gonna do a different one because it's one I'm used to doing, so it's gonna look different than this as well. Right? So, when you are doing yours, do it whatever way you want. Okay? As long as I can decipher what it is, it's okay. Right? Because you may be used to doing one at work if you've ever done this, or you've looked at them. Right? I don't want to like force mine on you either. Right? Okay? So this is the scenario that we have associated with that. Right? Right. All right, so we have other examples associated with this. So we'll be talking about some of these later on, but what I want to do now is to go through an example with you, right? A more specific example than what this has. Okay. All right, so we'll see how this works. So. Didn't want to do that yet. So let's go back. All right, so what I'm going to have out there for you to do is an assignment. So I know you've been waiting diligently for an assignment, nothing to do, right? So you have an assignment. Okay. Now, for this assignment, is you are going to be drawing some relatively simple ERDs. Okay. And the scenario is that I'm going to allow you to work in groups if you wish. So you can have up to 3 people in a group to work on it. But my expectation is if you're working in a group, right, that you are all participating and all that, right? So, right, you are all professionals. So I'm trusting that if you are submitting it as a group, that all of you have participated fully in doing that. The flip side of this is that you're going to do this on the exam, and if you don't participate, you're going to probably not be able to do it on the exam. So right, it evens out that you didn't participate, you don't get a good grade. Matches up. Right? So up to 3 people. You can certainly work individually if you wish, right? It's up to you, right? And you can certainly, if you know somebody in the online section or multiple people in the online section, you can get together and do whatever you want. Okay? So up to 3 people, only 1 person has to submit it. Just make sure all of your names are on it. Again, the format, as long as it's, so it can be the book's format, it can be the one that I'm going to describe to you, and it could be something slightly different, and that's okay, as long as I'm able to look at it and know that that's what you're coming up with. Okay? So, we are actually going to walk through the first one, so you see what it is. So, you only really need to turn in number 2 and number. Okay. All right. So, what I am looking for on this is that you are going to be able to do how many ERDs?
Per question,
Per question,
at least 2.
right? So you have a complete and you have a build. Right? So let's look at how you would go about doing this. Right? So if you look at each one of these, right? So you know, each section. Okay, so there's 4 of them that you end up doing, or 3 of them that you end up doing. Right? Each one has a couple of sentences. So right? Don't read like way more into this, right? I know that you guys are gonna think that there's not enough information here, so you're gonna like try to add a whole bunch of extra stuff. Resist the temptation. Okay? Right? So, in each one of these, there is a section, right, at the top, before it says the system is responsible for, that just describes, in general, what I'm looking for you to model. Okay. So, as soon as you get to the bullet point, stop. Don't even like consider it. Don't even read it. Right? Okay? Because the complete ERD is not based off of any system requirements. Right? That's what we said. Right? And I really like what he said, the way he described it was, give me the landscape of the whole thing. Does not give me what the system requirements tell you to do. It's give me the landscape of everything. Okay. Once you're done with that, then you're going to then go back and depict it or tell me what is involved in it. So what would be the build ERD that you would have associated with this? Okay. So each one of these is going to have two. A complete and a build. They may be exactly the same. They may be, the build could be a subset of the complete. Everybody okay with that? So the build is going to be based off of the system is responsible for. Right? So then once I have the complete, since the system is responsible for, what is it responsible for, and the steps to ultimately get there. Everybody okay with that? Okay. So let's think about what would be the steps that you would go about doing this. Okay. So if we look at the first one here, we say the user is a director of research for a large foundation. What are you modeling?
A large foundation.
The large foundation, right? That's what you're modeling. Is there an entity called foundation? No, because that's what you're modeling. You're modeling the whole foundation. So it's not an entity. So a lot of people will read, right? Here's what I'm doing, and they will create an entity for. No, that's not what you have, right? If I'm modeling the university, I don't have a university entity because the whole thing represents the university, right? Okay, so approximately 300 facilities are staffed by the foundation's 1,200 employees. Over 1,700 projects are currently underway, with some 350 waiting to be worked on in the future. Done. Stop. Right? So, if we look at this, what's the next step? You have to read it again and pull out the things. Right? So, how many things are we going to have? Right? Employee, project, facilities, right? So we have 3, right? Okay. Now, we don't have a bunch of attributes about this, right? Okay. So I'm not asking you to make up like hundreds of attributes about each one of these things, even though I know you can think of things for an employee and things for a project and stuff. So don't go crazy on this, right? But give me something like what you think a primary key of it would be, or some sample things, right? So don't go crazy on it. I don't want a lot, but I want a few. Yes?
In the real world, when you're developing complete ERDs, do you develop them with the same level of specificity that the project ERDs have, or are they at sort of different levels of specificity?
Okay, let me flip it around to you. because you ask me a question all the time, I can ask you a question. Okay,
Okay.
what does the word complete mean?
To me, it would mean, that's what we would want, I think, was at least that level of specificity.
Yes, you want, right? What's the T word we've talked about?
Traceability.
Traceability. Everything I find on a build ERD, I must be able to find on the complete.
Cool.
Otherwise, something's missing. Right? If I have it on the build and it's not in the complete, the complete one is wrong,
Or needs to be updated.
right? Well, it's wrong and it needs to be updated. Right? Okay? If it's on the build, I have extra on the complete, that's okay, but you should verify what you need of all the things that aren't transferred over. Do you have everything you need? Okay. And I trace it back to my requirements down there at the bottom. Right? So we'll see an example here, right? So what did I ask you to do? Minimum you can give me is just give me a primary key. So you gave me an entity called employee. So I have an employee ID. Okay. So if you look down here, and I ask you not to, so, right, we're out of sequence, only because of Cooper, right? Okay, but at the first requirement says list all employees in name sequence. So that must mean there needs to be a name attribute. If it's not on your diagram, but it's in here, then you need to add it, because it's something that we know and we can trace from what we know here back. Okay, so see how that works? Right? So we'd go, wait, someone's asking me for this, I can't get it, so therefore my diagram is wrong. And my starting point is always what? The complete, because it's already there. So did I answer your question?
Yes. Yes.
But it wasn't perfect.
That's close.
It was close. All right, so we have 3 entities, and we should think about at least an initial pass of what the attributes would be and what the keys would be. So we'll see how well this works. Here. All right, so this isn't in any super fancy format because I wrote this up in the couple minutes right before class because I said, why should I draw this up and when I have time between classes to do this? All right, so if we look at the top, we are modeling a foundation, right? So we draw this big box and inside it is the foundation, okay? Okay. We've read that it's 300 facilities, 1,200 employees, we have 2,050 projects, 1,700 that are underway, 350 in the future. So we have 3 entities, and I just drew them out there, and again, you can put them in any sequence in any place that you want. I just happen to put employee at the top, and facility and projects on the left and right. Right? So, and then I said, okay, in the employee, I'm going to say that there's going to be an employee ID number, right? And it's going to be the key, so I got it underlined, right? We have a name made up of first and last names, and they have multiple phone numbers. Right? So again, I was just trying to depict for you. So a lot of times what you will find is that your diagrams can get really complicated by putting all of this stuff together. Right? Especially if you have hundreds of attributes, right? It just gets like crazy. So a lot of times we will depict it just like this. We will have a separate diagram for each of the entities showing all of the attributes, and the general ERD will only show the rectangle showing the entities and then their relationships and cardinality and stuff. Okay. Okay. So again, whatever way you wish to do it as a team is okay. All right, so what is next? So we have gone through and we've identified all of the entities. We've defined what we believe are the current set of attributes. We know what we are modeling. So what's next? Relationships. So how would you determine relationships?
Requirements, go back to the requirements.
Absolutely not.
What?
What? What you accuse me of? You want to come up here? Taking me on. We'll get even, don't worry. Okay. All right. All right. Okay, so let's start off and talk about it one more time. We are creating which ERD? We're creating the foundation, but which of the two ERDs are we creating? Complete. Is there any requirements for a complete ERD?
No.
No. So we can't go back and look at them because we don't have it. We don't have a problem. What are we describing? The landscape. You have been describing, or you've talked to people that have told you about the company, the organization, the system, right? We talked about the ecological system, financial system, economic system, whatever system you want. They have described to you the landscape. And you are not putting it in a picture format, right? So Cooper really didn't mean to say that because I didn't even pay him, but he knew that that was a point that I really tried to get across to you, that you cannot jump to any type of requirements if you're going to do the complete because you don't have any. It's the entire complete picture of everything that is possible. That's the view you have to take of it. Right? So when we've created this, we have talked to lots and lots of people in whatever we are modeling to get all the different views of it, make sure we understand what all the names are and, right, see if, right, so we talked about aircraft, airplane, a plane, all mean the exact same thing, right? So people talk in terms of what they are used to and you have to narrow it down, right? So it's not, you're looking at the requirements, you're looking at the narrative of people describing the landscape. I love that word, right? And in future classes, I'm going to give you credit for that, even by name, okay? Is that okay? Right. All right, I will. Right. Okay, so it's important to cover all the things because this is the complete. This is everything that is possible. Okay. So the way that we want to do this is not we're looking at the requirements, we're looking at the entities, and based on our business knowledge, our knowledge of the system, the knowledge of the company, right? You are picking one of these. So for example, we pick employee. And what you should do is then take employee and look at every other entity that is out there and say, one by one, is there a relationship with that entity? And there either is or there isn't, or there could be multiple. And if there is, you draw it, and if there isn't, you move to the next one. Right? And you go all the way through. And then, what happens next? I move to facility. And what should I do with facility? I look at all of the other entities, even the ones I've already done, because I need to verify going in the other direction. Right? Is that one truly a viable relationship? And then you look at the one side, all the other ones, right? And you do that for all of those, right? So again, kind of looking at the ones you've already done is that traceability to make sure it's correct. Because again, you should read it, be able to read it forward and backward, and you want to verify it as many times as you need to. Okay, does that make sense? Okay, and then once you know the relationship, you can add the cardinality associated with that. Okay. So in doing that, so here is, so I use symbols, not just numbers, I use symbols to depict things. So in the example, you see on the relationship line, if I have 2 bars, right, that's what we call a mandatory one. So you have to have that, right? If I have a bar with a 0 on it, it's 0 or 1, right? If I have the open bracket, the line and the 0, it's 0, 1 or more. If I don't have the 0, it's 1 or more. If I have the symbol there, it's got 1, 2, 5. I can put a range, right? But the idea is that I can look at this and make a determination that that's what I want to see based on the symbol, not have to look at all the numbers and stuff like we saw in the other one. Okay, so I can just look at pictorially and see what it is. So if you look at the top, right? So I started with employee and said project. Right? So I said, okay, so what is my relationship? So employee is assigned to work on a project, right? And reading it the opposite way, because again, you should be able to read it both ways, right? Is the project has an employee assigned to it. Okay, so you should be able to read it both ways, but we write it so that the wording is top down or left to right. Okay. So if you look at this, we start with project, and we say how many employees would be assigned to a project. So you go away from it, right? So in our example here, a single project, we don't think about it, one and only one project, and you go up, and the symbol that you're putting up at the top end represents how many of the top one for one of these. So this says there is 0, 1, or more employees assigned to a single project. And coming down for a single employee is assigned to 0, 1, or more projects. Right? So one employee gets this symbol. The cardinality for a single project is the one at the top. Okay, does that make sense? Okay. Okay, so what's this one over here? Tell me what that one is. An employee works at how many facilities? One and only one. Right, it's got the double line. So it's a mandatory one. So one and only one. Right? So in our example back at the school, you as a student have one and only one account associated with you. And you have to have one. So it's a mandatory one, right? An account is assigned to one and only one student, right? So it's mandatory one on both sides, right? So it's all kind of, right? Okay, so, okay, what about a facility? A facility has how many? 0, 1 or more employees working at that facility, right? So what does that mean? It means I have facilities that have 0 people at it. So I could have a facility that's a power facility or something that you don't have any people at, right? But what if it always has at least one person? I'm gonna not have the 0 on there, right? So again, it's an employee works at facility and the facility has employees working at it. So I should be able to read it in both directions. Okay, everybody okay with that? All right. Okay, so now what do we do? We've done employee. So now we go to projects. Okay, and we reconfirm projects back to employee. Right? So, we already have it drawn, but we say, is this correct? So I'm doing it again. Do I have projects, a relationship to employee? Yes or no? I do. Right? And is it projects have employees assigned to them? Yes. I recheck the cardinality in both directions. Right? So a project can have 0, 1 or more employees working on it, and an employee can be assigned to 0, 1 or more projects. Good. So we are still correct. What about projects to facilities? We didn't have that, but there is a relationship. Projects are located at or worked on at, right? So some wording, right, at a facility. So a project is located at, worked on at 0, 1 or more facilities. And why do I know it's 0? If the project is not active and it's not being worked on. Just like a project may have 0 people assigned to it because it's not active. Right? Right? So you have to think through what the statements about the landscape are describing to you and make sure that they line up with what you're trying to do. Okay? Okay, so a project is worked on or located at 0, 1 or more facilities, and a facility can have 0, 1 or more projects that are being worked on at it. Right? So we verify that. Then what do? We move to facilities. Right? So again, what we do in general, we're not smart enough to recheck everything. We go, oh, the lines are already there, so it must be right. You should always go to every single one of them and revalidate what you had. So you should go to facilities, match that back up to projects, match it to employees, make sure the cardinalities are correct. Right? We should have verified, so we started at and looked at every single entity and compared every entity to every single other one, ensuring the relationship is correct, the cardinality is correct, I'm able to read it in multiple directions correctly, and verified, right? Because a lot of times what will happen is when we're making the rounds, that's when we add the second or third kinds of scenarios associated with that. Because a lot of times we have multiple relationships, right? Right? So is everybody okay with that? Mm-hmm. All right, so the next step is really easy. you number everything. And what did we number up here? Entities and the relationships. So we had 6 total things. Employee is number 1, the assigned to relationship is number 2, projects is number 3, the relationship located at is number 4, facilities entity is number 5, and works at is number 6. Okay, so I think all of you know how to number things, right? So that should be okay. All right. All right, so let's go back here for a second. All right, so now this is where we now go back to our requirements. Right? Because that represented our complete ERD. For each of the entities we had all of the, we had entity, we had all of the attributes that we believed were in there, we have all the relationships, and we have the cardinality, and we didn't take into account any requirements. We were looking at the landscape. And we've drawn what the landscape looks like. And it's got the 3 entities that are all directly related to each other. All right, so before we go on, is there any questions? Okay.
Yeah, so we actually mapped the cardinality and without even looking at the requirement. So I'm just confused. Say suppose tomorrow we come up with a problem set or a foundation which is like totally unknown to me. So how will I map up the cardinality if I don't look at the requirement? Like for example, you say facility and the project. Project to facility is like 0 or 1 or more. That is what was
Right, but the point is so let me take a step back. Right? Your requirements are what are you going to do with this? Right? So if you are at a company and you go to people at the company and say, okay, so very generic, how does your company work? How does this foundation work? Right? And they're going to say, well, we have, right? So again, they're just going to describe it to you, right? So we have these employees, right? And we have employees that are located all around the United States, because we have multiple facilities all over the U.S., lots of states, right? And we know that, right, we've got current projects that are being worked on, we have future projects that are proposed, right? And we keep track of the fact that the projects that are not being worked on are future ones because we don't assign them to any employees. And that also means since they're not associated with employees, they're not associated with, right? So you get the description about what the landscape is, just in general how it works. You ask questions to dig about the things that you don't understand, but it's not related to a project. Your specifications are, I want to do something with this data that already exists, or I can get. Right? So, all of the entities, all of the relationships, all of the cardinality is not dependent on a project because it already exists in the way that the company works, which is what you are depicting based on what somebody has written for you, described to you, you've interviewed for, whatever it is. Does that help?
Yeah.
Right?
So
Okay.
maybe after we read the problem statement, the actual requirements, we go back and will there be a need that we need to change it?
Sometimes, right? But again, right, to Cooper's point, right, for the complete ERD, you do not have a problem statement, right? If I could come up to you today and say, I would like you to take the next X number of months to create a complete ERD about the university. Talk to anybody you want about how it works. You go, what problem am I solving? I don't have a problem. I just want you to model what's going on data-wise at the university. So you don't have a problem statement. You don't have a set of requirements. You have how it works. Okay? Does that help?
Yes.
Okay. Because it's a really hard concept, because we, just like you guys want to do, you just want to jump into the problem. Right? This is, I want to model exactly what is going on in every possible way, not based on a problem. I want to know what are all the things, what are all the relationships, what's all the data, whether I use it or not, what's available to me. You're trying to get the big picture. And once I get a problem and I get some requirements, I'm going to select pieces of that that I need to solve that problem. And likely it's not going to be all of it, but I will know whether I have it or not. And if I don't, either my original diagram's wrong, or I have some work to try and figure out how to create whatever it is. So yes, when we get problem statements, there are times where we add a completely new entity and we add new attributes and things, right? Absolutely. That's the nature of organizations. So we create it once, hopefully you are not constantly updating it, but there is always a chance, given a set of requirements, for a specific problem, that you are going to have to change it. So probably I would guess, if I was to just kind of think back, that probably maybe 5% of the projects or less actually cause us to change the complete. We add to the build all the time because of new things, but it's adding on to what we've already built, not changing the complete. Okay, does that help?
Yes.
Okay. All right, so in looking at this, right, so now you come back and look and say the system is responsible for information regarding the current state of affairs only, right? So we want a list of all the employees in name sequence. So again, this is where you go, ding, 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 name. Do I have name as a attribute someplace because I'm looking for it by name? Did I miss it? Oh, it was on our list. Okay. List all employees who work at a particular facility. I want to be able to determine which facility has the most employees and which has the fewest. I want to display the names of all employees currently working on a particular project. I'm going to display all the project an employee is currently working on. I want to locate inactive, right? No employee assigned, so 0, right? So we know we got that one right. Okay, projects. And determine the ratio of active to inactive projects. Right? Right? So now we have to make sure that we can do this, because this is going to create for us the build. Right? Okay, so let's go back over here, and I kind of paraphrased it. Right? So if I want employees in name sequence, that's only number 1. Because that's the list of domain of all the employees. So I can get out of the domain of all the employees a list in name sequence. Right? So if that was my only requirement, what would the build ERD be? Just employee. because that's all I need. The other stuff exists, but I don't need it to satisfy the requirements of the product. So you see how this is working? Okay, so then we go to the next one, and give me the names of the employees at a given facility. Okay, so in this one, I need facilities, because I have to know the data about the facilities, but facilities only gives me facilities by itself. And employees only give me employees by itself, so I also need the relationship to tell me what employee is at what facility. So now, my build is 1, 5, and 6. Because those are the 2 requirements I need to satisfy. The rest exists, the projects is out there. It exists in the landscape. The other relationships, right, the assigned to and located at, exist. I don't need them. Okay. So, facility with the most and the least employees. Well, I get that out of something I've already built. So 1, 5, and 6, which I've already included in my build, are already there. So I satisfy this requirement with something I've already identified. So I haven't added to the build, but I'm able to reuse what I have to satisfy this requirement. Everybody okay with that? Okay. Okay. Employees that are on a project. Well, again, employees by themselves doesn't do that. Projects by itself doesn't do it. But I need projects, employee, and the relationship. So now my build is 1, 2, 3, 5, and 6. Okay. Okay. So list all of the projects for a given employee. Well, that's 1, 2, and 3, which I've already included. So that's okay. Okay. And then inactive projects. Okay. So inactive projects are what? No employees, and then we're going to do that is looking at is there a relationship or no relationships. So I still need 1, 2, and 3 to do that. Okay. Okay. And then the ratio of active to inactive. So it'll be 1, 2, and 3. Okay. So a lot of the requirements that I end up with, once I've already started coming up with what I have to build, already exist. Right? So those were the 7 things that we were asked to accomplish. So we have mapped them to what we had in the complete. Okay. So if I come down, right, my complete is 1, 2, 3, 4, 5, 6. It's everything. My build is going to be 1, 2, 3, 5, and 6 because there's no 4 in what I need to satisfy the requirements or the specifications. Right? So if I was to draw out what the build would be, I would leave number 4 off. Okay, does that make sense? Right. So what I do in mine, right, because I don't want tons of different drawings, I have one drawing. And I have it all nice in black to start, and anything I build, I turn So I have one picture, I can look at it and say, oh, here's everything that has been built already. Here's what's still possible. I've identified on the other ones, the attributes that I've actually used, stuff like that, so I highlight all the stuff, right? But I have complete and build all in one. Now, I've been at companies that they keep separate ones and stuff, that's okay. Okay? Now, what happens for the next project? You come in and you do the exact same thing, right? If it's a project for something you've already have a complete for, you're reading through it to see if there's anything new. Because if there is, I need to add it. If there's nothing new, I now start with the complete, and I look to say, what do I need from a build perspective? And what happens if it's blue in my case? I've already built it and it already exists in my application somewhere. So I don't, it's part of what I need, but I don't have to truly build it from scratch because it exists. Now, I then have to check and say, do I have all the attributes that I need? So sometimes you have to add an attribute because you didn't build it before. Something like that. But if it's all there, you just have the check to say, yes, that's my build. So I will create a build ERD for that particular project, right? But it's always going to overlay what I have, right? So I have one for each individual project, and I have one complete one that shows everything that is built. So the total build of, so, right, it's like taking the original complete and overlaying every build on top of it, because I want to know what the total build that I have completed. Because if I just look at individual projects, I don't use all the same things on all of them, and I can miss things, right? And rebuild something. I don't want to do that. I don't have enough time to do projects as it is. Okay? So, that's the concept that you are going to follow, right? So we did number one. So you're going to repeat number one, right? And then you're going to do 2 through 4. Okay. So for next week, before class, have it done, because what I'll randomly do is take some ones and so we'll take volunteers to walk through it, right? And you know, if you don't volunteer, I will just pick one, and then you got to do it anyway. So it's. But again, right? I want to make sure you understand there's different ways to approach this. So if somebody, what we show doesn't exactly match yours, theirs could be just as right as yours is. Different views. If the words are different, that's okay. Right? And if you already knew how to do this, you shouldn't be in the class anyway. Right? So I want to just walk through what you guys come up with, not just give you an answer, because I want to hear how you came up with what you did. Because it could be completely different than what I did, and it could be completely right. That's okay. And so we'll walk through the 3 of them, just so you do that. But so they need to be turned in before class next Tuesday. Okay. So you are, as I said, you are free to work in teams up to 3, as long as the expectation is met that the 3 of you, or up to 3 of you, work evenly on creating. Yes, Cooper?
Are there complete data dictionaries also?
Yes, kind of. Okay, so the reason I say kind of is because companies are so big and so large and nobody actually created one from the beginning that, wait, what are you guys, no packing up yet? We have that time limit that, Cooper negotiated for you guys, so I get to keep talking for a while, right? we don't get a break and you leave early. No, that's not the way it works. Right? I keep track of this time. Right? So, there is not a complete one because it's just a massive undertaking. Would you like one? Absolutely. And this is the way to help ensure that, right? But again, most companies don't even have complete ERDs, let alone a complete data dictionary. Okay, you got a second question?
Yeah, when will the assignment be available on Canvas?
I am going to release it before I leave this room. Because otherwise I'll get all these nasty emails saying, you gave us an assignment and you didn't put anything out there for us to even look at. So, if I don't get the nasty looks and nasty emails, I will do it before I leave. Yeah.
Do we have to submit translation and text? Or we can submit it?
You can submit PDF. Right? I don't care what it's on. If you want to go to the grocery store and you think about this on the way home and you're drawing it on the bag from the grocery store and you want to scan that, that's fine. Right? I don't care what it's on. I'm worried about the content. It can be hand-drawn. You can do some nice diagram thing. You can find some tool to do it in. Don't care. I just want you to submit the right content. So, I'm not worried about what it's on or what way you submit it. Right? That's why. Submit it and your work. Okay? All right, any other questions?
When is the due date? Oh, sorry.
Before class.
Before class. Right? Because I may just pick you.
And are we gonna get these sample things on the Canvas somewhere? Are you gonna upload?
I shouldn't have to. You understood all of it. You didn't have any questions. Huh? I gotta remember to even take these with me. I will not have them scanned it up tonight, but I will do that. Depending on how well the scanner works, okay? That's my, like, it's written in pencil, so I'm not sure how it's all gonna scan out, but.
That's just for it.
Right, but the flip side is you guys all get the access to the videos now, so you should, even if it's not out there, you have it. So, but I will put it out there because since you could look in the video and find it. But it would be more work for you guys, so maybe I'll put it out there. All right, with that, when does it due?
Yes. Next Tuesday,
What time?
before the class.
5:59 p.m.
Yeah, I will be sitting in the
You-
same class because I have previous class
Yeah.
of data
Okay.
management.
You upload it at 6:00:03. It's late.
So you don't want a hard copy, is that right?
Canvas is fine because we'll pull it right up here and
I mean, would you take a hard copy or?
would I take a hard copy? Yes, but you have to load it up to Canvas anyways.
Oh, okay.
But if you want to hand it to me for posterity, I would love to do that. I have lots of my student work up on my cubicle wall.
Oh.
Especially the team projects, because I always make them give me a team picture. So, yeah. So, I've got some great ones over the years. So, I had one where the team was freaking out because of the one student like took an exam and they like were like all crazed out by the exam that they just took. So they said, why don't one of the people on the team had a set of crayons. They said, why don't you just sit over there at the table and draw a picture of us and calm down. So I got that picture up on my wall, so they took a picture of themselves in crayon. Nice. So somebody did the caricature drawings of them. Other ones were pictures of them actually doing stuff. So I had one team that went to Mongolian barbecue before they opened, and they threw a bunch of CDs all over the grill, and they were standing behind theirs because they were cooking their data. I thought that was pretty cute. So I have lots of those and stuff. But if you want to give me a hard copy, that's great, but I'm going to grade the one that's in Canvas. So. All right. So 559.59.
Yes.
Okay. You got it.
If you guys care about voting on a break thing, you have until next week at 6 p.m. There's a discussion on campus and a link. If you don't care, whatever. If no one responds, then no one cares. That's fine. I don't even know what, yeah. Nothing. That's like literally their claim to fame. I do, yeah.
Thank you again for the great experience.
I just really, my name is Leah Wong.
Mm-hmm.
I just want to really thank you in
Oh.
person
No.
for like the permission of us.
Things happen, right? It's important that you handle whatever the situation is. We can work around anything.
Yeah, that would be
Right,
so
right,
sweet,
right.
yeah.
Yeah, so, you know, when you come back, we can figure out, you don't have to take it the day you come back or anything, right? So we'll figure it out,
Yeah, that
right?
would be
So,
sweet. Yeah,
you
we
know.
try to be back as soon as possible, as long as my new visa, the issue.
yeah, but again, don't worry about it, right? We'll figure out something to cover everything, so don't panic about anything, don't worry about anything. Stuff happens, we got it, we'll figure it out, you'll be fine.
Yeah, thank you. I will keep you updated.
Yeah, the last thing I want you to do is worry about school, trying to get through all this.
Yeah, I would love It's really interesting.
Good.
Yeah, because I have background mechanical engineering, so change to data science too.
Ah, okay,
Yeah, like data science, like.
there you go.
The way you teach is pretty effective.
Well, people say that I'm not like most of them.
Yeah, they're just reading the other things and then.
But this is what I do, so,
Okay, so cool.
no problem. Yeah, so when do you leave?
Probably, I give you Monday.
Okay.
Yeah, so I was still continuing.
No, that's fine. Yeah, so I was just wondering how long I was gonna see you. But, no, just keep, yeah, just send me an update.
Okay, yeah.
And it doesn't have to be every week or anything like that, just, if the status changed from the last week that you had. Let me know.
Yeah,
Okay.
thank you for the help.
No problem.